What's up, guys? I'm Brock, as you can see, and today I'm going to be going over how torque works and how it's applicable in my winch. Because if you guys have all seen my winch, you've seen me recover people with it. It's the tool that I use the most. It's amazing. And we're going to be going over this today because it's super cool and no one's getting stuck because all the trails are closed. Maple Springs is closed. Holy Jim's closed. Yeah, so let's get right into it. Alrighty, so let me start off by saying that torque is the rotational version of force. In physics, whenever you have an idea that's linear, for example, F equals ma, hopefully you guys have seen my video on that. If not, go watch it. It's a great video. But it's a rotational version of force, so whenever you have rotation involved, things tend to change a little bit. So the rotational version of force is tau. The Greek symbol tau is equal to moment of inertia times acceleration divided by the radius. And that's derived from the acceleration is equal to the radius times alpha, which is rotational acceleration. This part is kind of irrelevant for this video. I just wanted to throw it in so that you guys kind of have a grasp of how it all ties in. But we're mainly going to be focusing on tau equals F times D, or force times distance, because that's really how torque works. Okay, so starting off up here, we have, this is a little diagram of a wrench and a nut that I drew. This is every day. You get a flat tire, you got to change it. You're trying to, use your wrench, take off the lug nuts on your tire. But you have the force applied times the distance from the center point, which is right here in the middle, to the end. And that'll give you your torque, just that distance times the force applied. All right, so these circles down here, we're going to go onto those. And the smaller ones, they have a diameter of 1 inch. The bigger ones have a diameter of 2 inches. And this ties into torque. And this is how the winch is set up. There's, like a little, the green pins, those are the drive gear that has the force applied. That's like, think of it as like the motor, right? So that's the one that's spinning. That's the one that's giving the power. And when this is spinning, it's going to apply, these two are going to apply the same force. But as we saw up here, the distance from here to here is going to be greater than this distance. So this torque is going to be greater, because it's the same force applied, but this distance is greater than this one. Okay, and some people might say, Brock, aren't they just the same, but just like flipped around? No, they're not the same. And that's because these are the same force, right? But they might not look the same because this one's smaller than that. But they are the same force because this output force that would be right here, that's going to be the same relative to the radius of this gear right here. Just pretend it's a gear. All right. But those are going to be the same. And again, since this distance is greater than that, this torque is going to be greater. All right, so I hope that helped kind of explain a bit. I've got some questions on that before. I just wanted to make a little video about it. And that's kind of why, my winch is very small. I don't know, you guys have all seen it. But it's relatively small compared to what it's pulling. It has a 10,000 pound pulling capacity, and it's this little tiny thing. And it's able to do that because of these gear ratios that it's given when they're made. They're able to pull so much weight because of the torque that it's given. Alrighty, again, I hope that helped you guys, and I will see you guys all later. Thank you for watching.